So today we're supposed to investigate what effect multiple roots, roots that repeat, have on the graph when we sketch the polynomials. Well, you know this one. This is y equals x. So there's one x-intercept, just x equals 0. That's a single root. Graph goes right through the x-axis, no problem. Now this one I know that you know is y equals x squared. That could also be written that y equals x times x. And when we do the roots, we have two different cases of where x equals 0. So this is called a double root. And the graph is going to bounce when we have a double root. The official terminology is the graph will be tangent to the x-axis at that point. In this case, it'll be tangent to when x equals 0. Moving on, y equals x cubed. So you know what that graph looks like. Well, that's really y equals x times x times x. So we have three sets of x equals 0. Hence the name triple root. Now, when they want to get fancy about it, they say that the root has a multiplicity of 3. It just means it's a triple root. And the graph does cross through the x-axis at that point, but it flattens out a little, kind of like it has to battle its way across. X to the fourth. Quadruple root, or multiplicity 4. This looks a lot like the parabola, except between -1 and 1, it's much flatter. The reason for that is these are little fractions in here. And when you multiply a fraction times itself, it gets smaller. Like x equals 1/2, when you raise it to the fourth power, it turns out to be 1/16. So this is not climbing as fast. Once you get past x equals 1, then the x to the fourth will take up much faster than the x squared would. X to the fifth. Well, x to the fifth is going to look a lot like x to the third, except that it's going to be flatter. It will still cross, but again, these fractions in here are going to make the answers come out very small. And this would have multiplicity 5, because that one root gets counted 5 times. And they point out down here that for x to any power, the shape of the graph is going to look a lot like x squared if it's an even power. It's going to look a lot like x cubed if it's an odd power. And we're going to use those shapes not just at 0, but anywhere we have a multiple root.